So, hello everyone, my name is Anastasia. With some of you, we are already familiar, with some not. I work as a cybersecurity implementation engineer here at Labyrinth. And today we'll talk about Labyrinth, but more specifically about man-in-the-middle attacks and how we can detect them, how we can help in their detection. So, without any further hesitation, let's begin. We have plenty of things to talk about today. Okay, so before we proceed, let's start with the definition. What is man-in-the-middle attack? Man-in-the-middle attack, or MITM. It's type of attack that occurs when an attacker secretly intercepts and potentially alters the communication between two parties. So, from technical perspective, there are plenty of different types of such attacks. So, each exploits different weaknesses in communication protocols or network infrastructure. In other words, this attack can occur everywhere. So this term is rather really general and explains the general idea of what is going on. And today we'll be covering some of those, looking at them being detected. Okay, also a quick recap about Labyrinth. So Labyrinth Deception Platform, it's a cyber deception tool designed to provide fast, effective threat detection using decoys. And as you may guess, Labyrinth is deception tool. So the idea behind solution is that we place decoys in your network and we gather everything that happens to them, correlate these events and create alerts so that you can proceed with investigation. So the goal of platform is to mislead attackers into interacting with false resources. Okay, so as I said earlier, core and basis of solution is decoys. In Labyrinth, we call them points. So those are lightweight instances that serve as decoy services within the network. They mimic the behavior of legitimate resources, and this way we enticing attackers to engage with them and in turn trigger alerts. On the screen you can see the examples of those decoys, some of their types. As for now, it's important to remember that those decoys that can be customized because we'll be doing that a little bit later on. Okay, so returning to man-in-the-middle attacks, which points have such features? Which points can help us with detection? In general, there are two point types that are capable of doing that. First one is universal point. You may be already familiar with that. So universal point is a decoy that is intended to make complex simulations of the available in your network web resources in just seconds. We are providing the URL of what you would like to actually have. And besides that, it has capabilities to detect RP spoofing. On the other hand, we have ClientOS. So let's proceed and let's go over this in details and explain the relevance to meme detection. So once again, about universal point, it allows for RP spoofing detection. For this, we have a special part in config. Config in point config in Labyrinth is handled via YAML files, via YAML configuration files. And as you can see, we have a dedicated part for RP spoofing. This part is kind of similar to what we have for ClientOS. And let's proceed. So ClientOS, in general, it is a Swiss knife that has plenty of features. And the idea behind ClientOS is that it simulates clients' actions and creates noise to make your network, more alive, more engaging, more interesting for attacker to actually play around and make an attempt to find something that may be useful for further attacks. As you can see, to accomplish these goals, this point type makes the following types of requests. It's by default regular intervals of 30 seconds, but it can be configured. So it's host name and domain name resolutions. It's HTTP requests to specific web resources that you specify in your configuration. And also it can make requests for a list of file resources via SMB. And ClientOS can respond to net bias name resolution requests, adding another layer of realism to the decoy. So the point in general simulates client system, make it attractive target for attacker attempting to perform not only man-in-the-middle attacks, but in general a high variety of things that can occur to the decoy. So, and returning back to our topic, it detects more than universal point. It detects RP spoofing, it detects resolve poisonings, and it detects HTTP request interception. And we'll be delving into that, how we can configure it, what we can actually do. Let's proceed. Next, we'll be having a live demo. So we are done with the theoretical part. I try to make it as fast as possible. And now we'll proceed, as I said earlier, to a live demonstration of how Labyrinth detects man-in-the-middle attacks. So our first step will be configuring things. Today we'll be focusing mostly on ClientOS, but keep in mind that configuration of universal point is for this topic is the same, so there's nothing really special about that. And configuration of detection of the specified earlier attacks, it can be split in parts because, customization allows you to enable, disable functionality that you wish to have, that you don't wish to have, and etc. And for this matter, we will be also dealing with that in parts. So let's proceed. For this, give me just a second. For this, I will be showing everything right in the interface so that you get the general idea, so that you see how it actually works. So I have my Labyrinth ready. You see we have a dashboard. We need to go to the points, types, and in point types, we can actually create our configs. So I must say that this approach is completely optional. And in fact, you don't need to do any of that. Everything works out of the box. So you see we have predefined point types. So we can click on details. We see that this is default point type. It has its configuration. And you cannot do anything about that. But we have decided to create our new point config, and thus we'll be dealing with this form. We'll return to those fields a little bit later. Now we'll be focusing mostly on configuration. For this to work, we need to choose proper point type base. So point type base, this is like base that can be customized. That we will be working on. You can see list of available point type bases right from here. This is in general what you can configure, what you can customize for your needs. Okay, so once again, ClientOS will return, and we see config. So config, YAML config in Labyrinth has a structure. It's is pretty the same from pointer base to pointer base, as we have 3 parts that are optional, and we have services that should be specified in any case. So this optional part allows us specify fake ports that will be visible as filtered during network scan. We also can deal with our prefix, MAC prefixes, also an option, and services. So services is a part that is specific to each pointer base. It varies, and here we do the actual configuration of what this point is supposed to do, what it's supposed to emulate. Okay, so first thing that we will be dealing with is RP spoofing detection, also known as RP cache poisoning. So, as you know, it occurs when an attacker manipulates the RP table to associate their MAC address with the IP address of victim device. And by default, Labyrinth points, they are configured to have RP spoofing detection module enabled. So by default, it is enabled. If needed, if you wish, you can disable it, but why would you? And what also we can do here, we can specify a list of trusted MAC addresses that won't trigger alerts, so that we reduce false positives. So you see, it is as easy as it is. Configuration in Labyrinth, we made it with a thought of you not needing to have an additional document to actually understand how to configure things and how to make it work. So you see, everything is described in a form of comments. Okay, so that was really easy. From here, we don't need to do much because you see it's already enabled. I don't have any MAC addresses that should be trusted. This is our test environment, so that's all right. And we can proceed to our next step. So this part consists of multiple sections. All good? I thought I heard something, but okay. So this part consists of multiple sections that can be configured separately. They, in fact, in general, should be configured separately because you see all of those protocols that specified, they are, in fact, separate. They can work together. They quite often happen to be mentioned together, but yet their configuration is separate. So we won't be delving into each of them separately, but you will get the general idea to understand how it works. So each section, it has its own number of parameters. For our example, let's see. Let's have it, for example, mDNS resolver. So first thing first that you see, it's part of enable. You can disable this feature or enable. In my case, it's disabled. Also, you specify host lists that will be queried, so you know, multicast DNS. And what is important about that it will be really important when we will be doing an actual attack, is that those things, those hosts, they shouldn't exist, because if they exist, we will be dealing with man-in-the-middle attack. Why so? It happens, for example, the example that we will be covering today, by using responder. So host sends this request, like abc.dev.local, where are you? There should be no such host, but responder replies, here I am, and thus we can state that something is going on, something that shouldn't be working this way. And also here we have timeout. Timeout is needed, and this part is really popular because you know it. You see, those timeout settings are relevant to any resolver or client in config of ClientOS. And we have basic number of timeout. So this is a timeout between requests. And we have timeout shift, which is a deviation of timeout. So for example, if we specify 15, we will put timeout shift 5, then we get 15, 20, 17. You see, this is just to make it more of the variety so that it won't be, because it's really suspicious when your host sending requests strictly with the interval of 10, 20, or etc. settings, seconds. So just an example. And also what is important for understanding, for parts of mid detection activity, we specify this part of config, so you can search through it and proceed with your configuration. So the rest is kind of similar, so we won't be delving into that much. Okay, let's proceed. Next, we have configuration of TLS certificate authority check. This is what we are having for HTTPS request interception. How does it work? What should we do? So this functionality is part of, if we scroll down, of HTTP client. So the main goal of HTTP client is to send requests to the specified URLs. But in addition to that, what we can do, we can enable verified TLS, and this allows us for detection of HTTPS request interception. So we will be delving more into technical details how it works. As for now, we are simply defining what we should do in configuration. So first of all, we need to actually enable it. So we put the true. You see, also, if happens that you have internal CA, then you should put its certificate right here, because otherwise it will generate false positives, and we don't want that. And last but not least, what we should provide is a list of URLs that will be checked. And that's it. Also, is simple as it is. Okay, so we are good with that. And we will be actually heading towards testing those cases, testing what we can accomplish, what we can do. So in this part, in this I would say reteaming part, we will be also having a really brief theory part where I explain how this attack works. Then we will try that, and after that we will see some results. We will see what actually happens. So RP spoofing, we have already discussed what it is in general. And we will be trying to do some poisoning here. I really like this picture from the official EtherCub GitHub page. So it really explains what is going on. So we will be placing ourselves in between of two hosts. Quite often it happens that it is done between a device, like computer or something, and a network device, so that host, our attacking host, it impersonates itself as this networking device. So for this, we can do we can use plenty of different tools. I would say the most popular are RP spoof and EtherCub and its better version, as you can get from the name, Buttercup. So important to note here, because we are dealing with data link layer, we are dealing with MAC addresses, attackers, and weak teams hosts that should be in the same VLAN. So let us start the attack, and I will also explain some details. I'm sorry, let me just configure this thing. So we will connect to a virtual machine from where we will be actually performing some attacks. And usually one of the first steps that should be done is doing host discovery. Today we won't be doing that. By the way, we need to take my password. Give me just a second. I will get that. Okay. So let's do that. Yeah, so the first thing that usually happens during this attack, especially if we are using network for that stuff, it's not an option, it's a mandatory thing. It's host discovery. We won't be doing that. We will be skipping this part, and I will be using simply network. So for this, I will go to the points list. I will filter by honeynet. So for our convenience, I have created a honeynet with already generated points so that we don't need to wait for it to actually deploy. In general, this process is fast, but why not save time when we can do that? So you see, I have those points ready. We're returning back, and we will choose one of those hosts to be our victim. Okay, so let's type down our command. So we are using, as I said earlier, ettercap here because we like it old school, if you allow so. So we specify interface to use. We specify what exactly we will be poisoning because, in fact, ettercap is capable of plenty of different limit techniques, which is really good of that. So let's just copy IP address, for example, of this host. We put it right here. So, and then we need to specify a host that will be a second target. Let me just get this. It's this one, and that host is right here. So, seems fine to me. We can try. Okay, and now we should wait until we get some results. So this can take a couple of minutes sometimes, and we will be seeing. Let's go back to our stand, and we see that there is an RP spoofing attempt detected. So how does it work in general? It works that we check for the changes in RP table. So first change will be marked as RP spoofing attempt detected. It means that if we expand, we'll see that there is MAC address change detected. We see old MAC address, and we see new MAC address, which happens to be MAC address of my interface. And when there will be a second change, we will be dealing with RP spoofing finished alerts. So this is also a thing. Let's just stop the stuff that we are having. Let's go back. We will also need to wait for for a couple of minutes, but in what we have, we will be getting RP spoofing finished alerts. This will mark the second change in RP table. So in our case, this will be that RP table it returned to its normal state. So we see that RP spoofing has finished. If we expand it, we'll see that there's also a change. We see that MAC old is my MAC address, and MAC new is MAC address that we saw earlier. Okay, so that's good. We are great. We have gotten our results, and I believe that we can proceed. Okay, next we have some resolve poisonings here. This is also an interesting thing. As I said earlier, those protocols, they are configured separately. And how does it work? I made this simple illustration. Labyrinth point asks for some data, depending on the protocol that we are talking about. It asks if it's present. For example, we are checking if this host is available, if this host name is present right here. And from our design perspective, those values that shouldn't be real. We shouldn't be getting any responses or whatsoever. But in case of placing a tool, for example, what we will be using today, responder, we will be getting a response, and this will mark that, as I said earlier, something is wrong. So, oops, my bad. So for this matter, we will be actually playing around with that. So, as I said earlier, responder, let's use that. We will see what we gather. So here it is. Okay, so you see that we have some hashes. We already have some activity. And that's good. We see that something is going on. And I think that's enough for us. If we go back, we see that we need to refresh. We see that there are that we have already detected that there was some activity. And that will be enough for us because we have gathered what we wanted to get there. We got our alerts, but we can actually go further and see what exactly we have covered. For this, we can go and check logs. If I'm not mistaken, responder, it's logs, and we see some things. So there we will be having some hashes, and we can make an attempt to crack them. That's really simple. That's why we'll be doing that, because you see, the one of the ideas that I really enjoy with such webinars is that we are not doing really complicated stuff, because complicated stuff, it takes time. We are doing simple things. So you see, we haven't created anything new. We just use what we already have. We have predefined tools that can run without any additional parameters or without deep understanding of what is actually going on. But yet, those simple tools, they can cause harm to your network, to your assets, and that's why it's important to not to underestimate what we have. So let's see. And you see that we successfully gathered. We are lucky, so that we were able to actually crack those hashes, and we see that we have user administrator with a password admin. So also be sure to have your credentials secure. Also, a quick reminder that always should be kept in mind. Okay, so that was also great. I also forgot to mention that with all of those techniques, it's really important to be cautious because, for example, even if we are talking about demonstrational or test purposes, because, for example, even when performing RP spoofing that we have discussed earlier, it's critical to avoid disrupting the network. For example, if you accidentally poison the RP cache of, for example, default gateway, then the entire network might lose internet or segment connectivity. So be cautious when specifying victim and attacker. And it also happens when we are using responder. It's also important to be cautious of your network to understand what is going on, not to destroy everything. Okay, so we are also great with that. And I suggest that we can proceed to our next case that we'll be covering. So with the results, we see that we see our alerts. Everything is great. By the way, what is also cool about Labyrinth is that you can change statuses. Really simple. You just specify new status. Reason you can do absolutely the same using API. So to do that automatically, but as you see, there are options. Okay, everything's great. So let's proceed. Our last case for today will be HTTPS request interception. So what is a thing about that, about this verified TLS option that we have discussed earlier, is that as a part of PIN protection, we really do not care about everything but TLS certificate, which is signed by known authority. So it means that certificate may be self-signed, it may be expired, or it may be misconfigured. So for our detection, it must be signed with known authority, and that's all. So that this way we will be avoiding false positives, because it happened that your certificate is expired, you just forgot to refresh it. Sometimes happens to all of us. So we won't be triggering that as a alert. So what about our lab? What we are dealing with today? If we go back to our points list, so we will filter by honeynet. My bad. It's honey 3. All of them are of the same type, so it doesn't matter what we choose. What we can see is that for HTTP client here, I have where is it? Verified TLS is enabled, and we see that for URL list we have our website. This is our website. But what has happened? What I have prepared for this demonstration, I played around with our test DNS server. And happens that this DNS records points not to our original website, but to my host, on which we will be getting some data and forwarding it next to our website. So as usual for this type of attack, we will be placing ourselves in between. So let's try. So for this matter, I will be using MITM proxy, also really popular tool. There are plenty of tools also that can be used, but I really enjoyed MITM proxy for debugging purposes. Also cool stuff. Easy to use, easy to configure. Let's run. Okay, so now what we are doing here, we are waiting for some activity. Oh, and we already have something. This is great for us as attackers, and this is not as great for us as clients, because you see we are intercepting that. And what is also going on is that my MIT proxy, it has generated its own certificate. So it's done by default if you go and check documentation. But it has its own internal CA. I haven't put its certificates right into configuration. Remember that we were talking about when we actually discussed point config. And it means that this certificate check, it won't be successful. And we can go and check that. We go to the alerts once again, and we see that there was unverified TLS certificate of HTTPS server detected. This is exactly what we were doing, that's what we were actually trying to achieve. And by the way, about the interface, you can not only go to alerts, you can also get it from this side menu. You can also retrieve alerts via integrations, via API, also options for your further investigation. And that's pretty all from a technical perspective that I wanted to show to you. So as I said earlier, you see that it's really simple. It doesn't take much of knowledge, much of resources to perform those attacks. But even though we did it in a simple way, just to demonstrate how it works, how it detects, more sophisticated attackers that are actually trying to do harm to a network, they won't be so. They will be more dedicated to this topic. So that's why it's really important to keep an eye on what is going on in your network. And this is when deception can really help you with a little resources. We get such results. What I also have an important note. It's what I wanted to add. It's not specifically about our topic, but it's I would recommend subscribing to our LinkedIn channel, not just because I work for this company and it's my job to do some kind of marketing here, but also because we are planning to announce some major improvements, major things that will be added in the upcoming release. It will be in October. And this new feature, it will be available for everybody. Even if you just start a POC, you will be able to play around with that. So keep an eye on that. I can guarantee that you will be interested in that. But unfortunately, I cannot tell you more details as for now. And where to meet us? We really like to meet our audience, our clients, our partners live. And for this, we have a number of events that we will be attending. The number of events may be increasing because we have new opportunities. But if happens that you will be there at that time, we would be really glad to meet you. Just drop us a line and we will be great to discuss. If it's a conference, we will also grant you with some stickers. Okay, so thank you so much for your attention today. Keep tuned and keep safe. I hope everything is fine.